Guys, last lesson 4-5, systems of linear inequalities. So the difference between a system of equations and a system of inequalities. Before, what you would do is you would draw both lines on the same graph, and you'd be looking for the intersection. When you found that intersection, I would ask you for the coordinates for the x value and the y value, and that would be your answer for the system of equations. Now, the difference with a system of inequalities is because there's shading involved. You would have one line shading one direction and another line shading another direction. Your answer is not this point. Your answer is the overlap. So for example, the solid line is here with the red, so there's overlap here, and this green shade is also with the red shading, so other points over here would also be answers. Now, we don't call this infinite answers. Basically, the answers have to be in this section of the graph, and that's where your answers are. So there are multiple answers that work for a system of inequalities, okay? So to solve these, you have to graph and identify this like overlap area, okay? So let's practice right here. Let's do this in two colors. So I'm gonna do the first one in blue. So this graph is starting at +1. The slope is 2, so it's going to be 2 over 1. So 1, 2 over 1. Okay, what kind of line is it? It's a solid line because it's equal to. So I'll draw a solid line going this way. Okay, and now for the shading. Y is greater than the line. So greater than is above. So I'm going to shade above the line up here. Okay. Now, normally you would be done here, but because this is a system, the second equation has to go in the same graph. I'm going to do this one in green. This line starts at 2. The slope here is 1, so it's 1 over 1, up 1 over 1. And this line, though, is going to be a dashed line. Okay, like that. And this line also says greater, so above will be up here. All right, so this looks kind of messy, right? But you have to remember, here's one line, and here's the other line. Okay, we're looking for the overlap. The overlap is up here, so my answer is in this section only. This is where my answers are, where the shading happened twice. Okay, so that's basically it. That's how you graph these. Let's do one more. Okay, this one has a starting point at 0 because there is no b. The slope is 2, so it goes up 2 over 1. It is a dashed line. Next time I should get some crayons so that I can kind of shading with pens. There's no real way to like do it lightly. Okay, the other line. Oh, the starting point is -3. 1, 2, 3. And there's no x, which means there's no slope. So this is a horizontal line, and it's also going to be dashed. It's going to be a dashed line. So I'm doing it this way just so maybe you can see what it looks like as lines. But you can't forget the shading part of it, okay? As far as the shading goes, the way it works is we're going to shade for the first line, y is less than. So we're going to shade over here, less than. Actually, that works pretty well. This is less than the line. Y is greater than, so greater than the line would be up here. Where is the overlap? Now, the answers can't be on the lines because the lines are dashed. The dashed lines are not part of the answer. The answer is in the area here. So your answer is in here, where the overlap happens. And that's where your answers are. Okay? All right, now let's write some inequalities based off graphs. So let's go to example 2. Okay, so for example 2, Let me show you some graphs. This graph has two lines in red and blue. I'm going to use red and blue to kind of write this. Let's start with the blue one. It looks like it's at -1, but if you have to be very careful because it's not counting by ones. Every line is actually 2. So that line actually starts at -2. Then the slope, it looks like it's going up and over, up 1 over 1, up 1 over 1. And because it's counting, it's really counting up 2 over 2, but if you reduce that or simplify that, 2 over 2 is 1. So the slope is 1. And now I just have to decide what symbol I want here. Well, it's solid line, so I'm going to put a line underneath it. And it's shading below, so I'm going to put less than. So it would be this. And actually, if it was multiple choice, though, you would see this. You would see this. Let's do the red line. The red line is on the positive side, so it is a +2. The slope is kind of weird because I can't count up all the way, so I kind of have to work my way backwards. I'm going to go left 1 and down 2. So if I draw that, it looks like it's going up 6 over 2. So with 3, the slope is 3. It is a solid line. It is shading above the line, so y is greater. And this is the answer. This is the system right here. This is the answer for this. Okay, let's do this one. Since I have red in my hand, let's do it with the red line. The red line starts at 0. Okay, 0. The slope looks like it's going down 1, 2, 3, 4. 4 over 1. No, 4 over 2. So that simplifies to -2x plus 0. Now, it's not a solid line, so I don't draw a line underneath it. And it's shading above. So it's like this. It'll look like this. I'm going to simplify this a little bit. Y is shaded above. It's not a solid line. And the slope is -2x. And it started at 0. I don't write down 0. And that's the first line. The blue line starts at -4. The slope is going up 2 over 4. Up 2 over 4. Simplify that. Up 1 over 2. So it's 1/2. This one is a solid line, so I'm going to put a line underneath this. And now I have to decide, is it shading above the line or below? It's shading below, so y is less than, and this is the second graph. That's the second answer. Okay? Now, sometimes you're going to see graphs like this. And guys, this graph has no solution because the shading doesn't overlap. You see the equations right there for these lines? But those would be the inequalities you have, but there is no overlap. There is no solution in this one. Okay, just want to show you that real quick. All right, let's go to the word problem next. All right, let me make this a little bigger. Okay, now this word problem. Malia has $500 to purchase water bottles and a pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of 200 items without buying too much of just one item. So what graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? So let's first treat this like an equation. If you guys remember when I told you to do equations, I told you you should always start with the totals. The totals are very important, all right? So for these totals, what we're going to look at is we're going to actually look at the $500 and the $200. So let me move this down a little bit. So my totals are 500 and 200. $500 is the goal. You have to buy 200 things. Now, normally if this was an equation, I would just say, okay, what are the two things we're buying? Socks and water bottles. Okay, so we have the socks and the water bottles are the items you're selling. We're going to have the socks used as X because we don't know how many of them we're buying. And we're going to use the water bottles as Y because, again, we don't know how many we're buying. Now, if I were to do this as an equation, the way the equation would work is I would add up all the water bottles, and sorry, all the socks and the water bottles, and that would give me 200. But for the amount for the fundraiser, each sock is going to be sold for $3, and each water bottle will be sold for $2. Let's just say pair of socks. Now this would be the way you set up the equations, right? Well, the problem is we're using inequalities, okay? So we have to get the idea behind the, the goal and the amount of items as inequalities, okay? So a little bit of logic here. If you're going to buy this many items, right? This is the amount you want to buy. You need to look at the way it's phrased. She needs to buy a total of at least 200 items, which means this can be 200 items, or it can be greater than 200 items because they'll sell more. So this can be greater than or equal to 200. The amount that you buy can be greater than or equal to 200. Now for this one, you have a goal of $500. I'm sorry, that's not the goal. That's the budget. You have a budget of $500. So when you're looking at a budget, this is the maximum amount you can spend. You cannot spend more than 500. You can't go over your budget. So these things have to be less than or equal to 500. So let me write these things down now a little bit nicer, a little bit clearer. 3x plus 2y less than or equal to 500, and then x plus y greater than or equal to 200. Okay, this is what we got. Now, if we're going to graph these, I don't want to graph them like this. I want to change them to y equals mx plus b, or slope-intercept form. So we're going to change them both. Now this one is a very straightforward way to move it. If I move the x to both sides like this, my equation will be y is greater than or equal to negative x plus 200. I'm good with that. The top one's going to be a little bit more work. This one was an easy move. This one won't be so easy. So let's do a little bit of work here. To move the variables around so that y is the only letter here, we start by moving the 3x, and that'll leave you with 2y less than or equal to minus 3x plus 500. But now the 2 has to go. So that 2 has to cancel out. So I'm going to divide by 2. I apologize for the background noise. We're going to divide by 2. Everything gets divided by 2. That will leave you with a y. That'll give you a slope of 3 over 2, and that'll give you a starting point of 250. Now, this is what I'm going to graph. They represent the same inequalities. They're the same inequalities, but I'm going to graph them using this. So now for my graph. Okay. To make my graph, I'm going to count by 50s. So 50, 100, 150, 200, 250. Now, why did I choose to count by 50s? Because my starting points, I want my starting points to be very clear. All right, if I'm counting that by 50, I should count these by 50 as well. It just makes it easier to do slope if I count them the same. If you don't count them the same, it's going to make your slope a little bit harder to do. Okay, so the first line starts at 200. The slope is down 3 over 2. So I can count the spaces to do this because I have the same intervals. So down 3, 2, 3 over 2. 1, 2, 3 over 2. So my line will look something like this. Yeah, if you notice, I did have to go into the negative side but I'm not going to count this because we're not using negative socks, okay? So don't worry about that. So right here is kind of where it stops at 0, like around 160, 170. Okay, the other line starts at 200. Oh wait, I should shade, but let's shade it afterwards. The second line starts at 200. The slope is -1. So down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. So this line, let me try to draw it straight first. And I missed it. I missed the line. See, that's why you have to be careful. I missed it the first time. So that's my line right there, the darker one. Okay, now for the shading. The first line I did said y is less than, so I'm shading right here below the line. Okay, right here. This one is a little different. This one says y is greater than. So when the y is greater, we're looking at shading above. So we're going to shade above the line. Up here. Okay. So I'm looking at this. And I think it gives me ideas of where my answer should be. All right. So my overlap. Remember, you're looking for your overlap. Your overlap is kind of in between these spots right here. Right here. This is where my overlap is, right here. Okay, so what does this mean? That means that any point in here is a good amount of purchases. So if we're trying to keep it even, I'd say somewhere around 150 for Y and around like 50 for X would be a good place to start. Somewhere around here. I think that would be good. So this, any point in here is good, but if we're trying to keep it balanced, I don't want to go all the way to 250. 150 to 50 might be good. So that means that my coordinate would be 50 and 150. And X would be the socks and Y would be the water bottles. So a lot of more water bottles than socks. That's how I would do it. That's how I would graph this.